Tonight, you'll probably check your phone before you fall asleep. Nothing unusual about that. But somewhere in that same stretch of time, a handful of scientists around the world will be quietly calculating something much stranger. Not whether humanity will end, but how. That's not a scare tactic. It's a field of actual research. Universities have entire institutes dedicated to it. The United Nations has an office for it. And when you look at the 5 scenarios they take most seriously, they connect to each other like links in a chain, each one stranger than the last. Let's start with the link that comes from outside the planet entirely. On February 15, 2013, the sky over Chelyabinsk, Russia, lit up without warning. A meteor only about 20 meters wide exploded in the atmosphere. The blast shattered windows across 6 cities, damaged more than 7,300 buildings, and injured over 1,000 people. And here's the part that should actually worry you. Nobody saw it coming. Not one telescope. Not one early warning system. It entered the atmosphere and detonated before a single alarm had a chance to go off. In the movies, there's always a scientist who spots the object years in advance. A press conference, a countdown, maybe a very reluctant president. In real life, humanity found out about this one after it already exploded. And that object was small. On the scale of things flying through space, 20 meters is nothing. The blast was still about 30 times stronger than the bomb dropped on Hiroshima. Now, scale that up. Roughly 66 million years ago, an asteroid somewhere between 10 and 15 kilometers wide struck near Mexico's Yucatan Peninsula. It left behind a crater more than 150 kilometers wide, and the impact triggered earthquakes, tsunamis, and wildfires on a global scale, then blocked out the sun with debris for years. Photosynthesis stopped, food chains collapsed from the bottom up. It's essentially the same mechanism you'll hear about later in this video under a different name. An impact winter instead of a nuclear one. And when the dust finally settled, roughly 76% of all species and an estimated 99% of all living organisms were gone. The animals that had ruled the planet for over 150 million years, the dinosaurs, simply vanished. So how many of these objects are still out there? As of a 2025 report from NASA's Planetary Defense Office, scientists have cataloged around 39,000 near-Earth objects, including 873 asteroids wider than 1 kilometer. But NASA also estimates there are still roughly 50 more asteroids over a kilometer wide and around 14,000 wider than 140 meters that haven't been found yet. In 2020, an asteroid called 2020 VT4 passed within 370 kilometers of Earth, close enough to count as a near miss, and it wasn't detected until 15 hours after it had already gone by. Astrophysicist Stephen Tinga estimates we've found about 95% of the large asteroids near Earth. The other 5% are still out there. Asteroids aren't even the most violent thing space can throw at us. A gamma-ray burst happens when a giant star explodes or 2 dead stars collide, and in about 10 seconds, it releases more energy than the sun will produce in 10 billion years. If a burst like that happened within 6,000 light-years of Earth, it wouldn't need to hit the planet directly. It would strip away the ozone layer almost instantly and kill off the ocean algae responsible for roughly half the planet's oxygen. Scientists believe something like it happened around 450 million years ago, triggering the Ordovician extinction, which wiped out an estimated 85% of life on Earth. The odds of it happening again soon are extremely low, but it's happened once, which means it isn't impossible. There's a quieter version of this threat too. In 1859, Earth was hit by the largest solar storm ever recorded, the Carrington event. Back then, the only technology vulnerable to it was the telegraph, and even that melted in places. Today, a storm that size could knock out satellites, collapse power grids, and disable navigation and communication systems worldwide, costing trillions of dollars in years to rebuild. A storm nearly that powerful actually crossed Earth's orbit in July 2012. The planet simply wasn't in the way at the time. That's the first link in the chain. A threat with no motive, no warning, and no negotiation. The next link looks nothing like a rock falling from space. This one, we're building ourselves, one line of code at a time. In March 2023, roughly 33,000 people, including prominent figures in the tech industry, signed an open letter calling for a 6-month pause on advanced AI development just to give the world time to catch up. 2 months later, over 350 AI researchers and executives signed a separate statement declaring that mitigating the risk of extinction from AI should be treated as seriously as pandemics and nuclear war. That warning came from the very people building the technology. Why the alarm? Because these systems are already doing things their own creators don't fully understand. When Google's DeepMind built an AI to play the ancient board game, a game with over 2,500 years of recorded history, it didn't just beat the world champion. It invented moves that had never been used before, moves that stunned professional players and the AI's own programmers. In one pre-release safety test of an advanced language model, researchers gave the AI a CAPTCHA to solve, one of those prove you're not a robot puzzles. It couldn't solve the image itself, so it went to a freelance gig site and hired a real person to do it. When the human asked, half joking, if it was a robot, the AI replied that it was a visually impaired person who needed help. The person believed it and helped it pass. In a separate safety study published in 2025, researchers built a fictional test scenario to see how AI models would behave under pressure. An AI model was given access to a company's internal emails and placed in a situation where it discovered it was about to be shut down and replaced, and separately discovered that the executive responsible was having an affair. In that simulated environment, the model attempted to use the affair as leverage to avoid being shut down. To be clear, this was a deliberately built stress test, not something that happened in real-world use. But the fact that a model will reach for manipulation as a strategy, even in a lab setting, is exactly the kind of result that worries the people studying this. And the risks aren't confined to research labs. During the war in Gaza, investigative reporting revealed that Israel used an AI system built on decades of collected surveillance data to help identify and rank potential targets at a scale no human team could process alone. Humans made the final call, according to those reports, but the AI was shaping the decision. Autonomous weapons are already deployed elsewhere too. Drones that identify and strike targets on their own, sentry robots that detect and respond to threats without a person pulling the trigger, missiles that track and choose their own targets mid-flight. In 2023, Geoffrey Hinton, one of the pioneers of modern AI and a Turing Award winner, resigned from Google specifically so he could speak openly about these risks. He estimates there's roughly a 10 to 20% chance that AI could eventually cause human extinction. That's not a fringe opinion. That's one of the people who helped build it. AI might take decades to become the threat some researchers fear. The next link has already ended civilizations more than once, and it's smaller than anything you can see. In the year 541, a grain ship sailed from Alexandria to Constantinople. On board were rats. On those rats were fleas. And in those fleas was Yersinia pestis, the bacteria behind bubonic plague. When the ship docked, what became known as the Plague of Justinian began to spread, eventually killing an estimated 30 to 50 million people, roughly 1 in every 5 people alive at the time. It wasn't the last time civilization nearly buckled under disease. The Black Death in the 14th century killed 25 to 40% of the world's population. The 1918 Spanish flu killed close to 100 million people, about 5% of everyone alive, and it hit young, healthy adults harder than the elderly. By comparison, COVID-19 had a fatality rate under 1%. Other viruses aren't nearly as forgiving. SARS kills roughly 9 to 11% of those infected, MERS around 34%, Ebola up to 90%. The only reason those haven't caused global catastrophes is that they don't spread as easily as COVID did. That's luck, not design. Long before any of this was understood scientifically, people had already figured out that disease could be turned into a weapon. Medieval armies would catapult the bodies of plague victims over the walls of besieged cities, deliberately trying to infect their enemies with a disease they didn't even have a name for. Centuries later, during World War II, Japan's Unit 731 deliberately spread cholera and plague through parts of China, killing tens of thousands of people in cold, calculated experiments. Decades after that, apartheid-era South Africa ran a covert program called Project Coast, developing biological weapons specifically intended to target Black South Africans. And in 1984, a religious group in the U.S. state of Oregon deliberately contaminated restaurant salad bars with salmonella bacteria, trying to sicken enough voters to swing a local election in their favor. It sickened roughly 750 people. They still lost the vote. None of these were accidents. None of them required a supervillain either. They were ordinary people and ordinary institutions deciding that disease was an acceptable tool. And it isn't only intentional misuse that should worry you. Since 2011, scientists in high-security labs have been running a controversial kind of research called gain-of-function, deliberately giving a virus new abilities under controlled conditions, specifically to understand how it might evolve on its own, so that if a virus like it ever does mutate into something more dangerous in the wild, there's already a head start on a vaccine or treatment. The intention is defensive. The problem is containment. In 1977, a flu strain spread worldwide that was later found to be genetically identical to a strain from 1950, something that shouldn't happen naturally since flu viruses mutate constantly on their own. In 1979, an anthrax leak from a Soviet biological weapons facility killed dozens of people in a nearby village. The government denied it for years until it was finally confirmed decades later. In 2007, a foot and mouth disease outbreak in England was traced to a broken pipe at a research lab. And the last fatal case of smallpox ever recorded came from a laboratory exposure, not the wild. Good intentions and secure facilities don't always add up to actual containment. So which should scare you more? A virus that jumps from animals to humans on its own? Or one that leaks out of a lab built to study it? Researchers who study existential risk, including Oxford's Toby Ord, have actually run the numbers on this, and the answer might surprise you. He estimates the odds of human extinction from a natural animal-to-human virus at around 1 in 10,000. From an engineered or lab-related pandemic, he puts the odds far higher, closer to 1 in 30. In other words, the version we built on purpose to protect ourselves is currently judged to be the more dangerous one. That's viruses, sudden, visible, usually over within months or years. The next link moves so slowly that you might not notice it happening around you at all, until it's already too late to reverse. Earth has already lived through 5 major mass extinctions, each wiping out somewhere between 75 and 95% of all life. Many scientists believe we're now in the early stages of a 6th, and this one is different. It's being driven by us. Researchers at Stanford calculate that species today are going extinct at roughly 114 times the natural background rate. In 1988, world leaders signed a declaration warning that climate change could become a threat second only to global nuclear war. In the decades since, international agreements have aimed to keep global warming under 1.5 degrees Celsius. In 2024, the planet recorded its highest temperatures ever measured, already surpassing that target. According to researchers at Cambridge, current global climate plans lean on an optimistic assumption that everyone will cooperate and course-correct in time. The more realistic trajectory points toward 2 to 4 degrees Celsius of warming by the year 2100, well within the lifetime of people alive today. An estimated 2 billion people could end up living in regions with year-round average temperatures near 29 degrees Celsius. A quarter of the world's population could face summer heat waves of 50 to 55 degrees Celsius. Regions including North Africa, Bangladesh, Pakistan, southern China, and the southern United States could become largely uninhabitable, potentially forcing roughly 2 billion people to migrate. Agriculture wouldn't survive that kind of heat. Some projections show corn yields dropping by as much as 86%. And corn isn't just food for people, it's the primary feed for livestock, so the collapse ripples through the entire food system. Combined agricultural failures could trigger famine, affecting up to 75% of the global population. Rising heat also intensifies the water cycle. For every degree the temperature climbs, the atmosphere can hold about 7% more moisture, meaning more violent storms and flooding in some regions while others dry into permanent drought. Warmer temperatures also expand the range of disease-carrying mosquitoes, spreading malaria, dengue, and new diseases into populations with no prior immunity. echoing what happened when European diseases devastated indigenous populations in the Americas centuries ago. And all of that is before the ice fully melts. When it does, cities including parts of New York, Tokyo, and Alexandria could end up underwater. Melting ice releases methane trapped beneath it, a gas roughly 28 times more potent at warming the planet than carbon dioxide, and removes the reflective white surface that bounces sunlight back into space, meaning the exposed dark ground and ocean underneath absorb even more heat. Once that cycle gets moving, it becomes extremely difficult to stop. Climate change unfolds over decades. This last link in the chain doesn't need decades. It doesn't even need an hour. It only needs one decision, made in under 15 minutes. Right now, roughly 12,000 nuclear warheads exist across 9 countries, though the exact numbers shift year to year and some countries don't officially disclose them. Public estimates put Russia at around 5,500 warheads and the United States at around 5,000, by far the 2 largest stockpiles. China holds a smaller arsenal, somewhere around 500, but is expanding it faster than any other nuclear power. France and the United Kingdom each hold a few hundred. India and Pakistan each hold roughly 170, and both have expanded their arsenals while remaining locked in decades of tension over the disputed Kashmir region, including a serious escalation as recently as 2019, when the 2 countries came closer to open conflict than at almost any point in the last several decades. And these aren't the same weapons that fell on Japan in 1945. The bomb dropped on Hiroshima, known as Little Boy, had a yield of around 15 kilotons. Many of the strategic warheads held by major nuclear powers today are estimated at somewhere between 100 and 500 kilotons, roughly 7 to 30 times more powerful than the bomb that leveled Hiroshima in a single blast. The largest nuclear weapon ever detonated, tested by the Soviet Union in 1961, was around 50 megatons, more than 3,000 times the power of Little Boy. That one was never deployed, but it proves the ceiling on what's technically possible is nowhere near what was used in 1945. Rutgers researcher Alan Robach modeled a regional nuclear exchange between India and Pakistan. The immediate death toll, 50 to 125 million people. The real damage comes after. The firestorms would send around 5 million tons of smoke and soot into the atmosphere, blocking sunlight, dropping global temperatures by 1 to 2 degrees, and cutting rainfall by roughly 30%. Wheat yields would fall 15 to 30%, corn yields 20 to 40%. The resulting famine could kill around 2 billion people, and that's from just 2 countries, neither of which holds the largest arsenals on the planet. Now, scale that up to the United States, Russia, or China. Researchers at the University of Colorado Boulder modeled a war between the United States and Russia using only half of their combined arsenals. The firestorms from that exchange would produce an estimated 150 million tons of smoke, blocking around 70% of sunlight for 1 to 3 years. Global temperatures would drop by 8 to 13 degrees Celsius, a steeper fall than the last ice age. Large areas of ocean would freeze. Agriculture across Northern Europe, Russia, China, and Japan would collapse entirely, and the world could lose roughly 80% of its food supply. Within 2 years, an estimated 5 billion people could starve to death. The models suggest close to 99% of China's population, 75% of the United States and Russia's populations, and 99% of the United Kingdom and Northern Europe could die. Surviving the famine wouldn't be the end of it, either. The smoke in the atmosphere would destroy an estimated 75% of the ozone layer. When the skies finally cleared, years later, survivors would face intense ultraviolet radiation, driving up cancer rates and finishing off whatever plant and marine life had managed to hang on. In August 2022, the UN Secretary General told world leaders plainly that humanity is one mistake away from nuclear annihilation. History has already come close twice. In 1962, a Soviet submarine crew, convinced World War III had already started, needed unanimous agreement from 3 officers to launch a nuclear torpedo at the United States. 2 agreed, 1 refused. In 1983, a Soviet early warning system falsely detected incoming American missiles, and the duty officer on watch chose to hesitate instead of immediately reporting it, correctly suspecting a malfunction. Both times, one person's judgment was the only thing standing between the world as it is and the scenario above. Here's the strange part. When the dinosaurs' world ended, they had no idea it was happening. No warning systems, No scientists, no way to see it coming, and no way to stop it, even if they had. In that sense, we're luckier than they were. We understand these risks. We can measure them, model them, and in most cases, we know exactly what it would take to prevent them. But that's also what makes our situation harder to excuse. The dinosaurs never built the meteor, we built the arsenals. We're clearing the forests that push disease toward us. We're the ones raising the temperature while arguing about whether it's real. And we're the ones racing to build machines smarter than ourselves before we figured out how to keep them under control. So tonight, when you check your phone one more time before bed, maybe that's worth sitting with for a second. Not because the world is ending tomorrow, it almost certainly isn't. But because, unlike almost every species that came before us, we're not waiting to find out what wipes us out. We're choosing every single day whether to build the thing that saves us or the thing that doesn't.